Assalamualaikum, my name is Amira binti Aswi, 2240232 from YTSI. I will talk about core concept in computer graphics. So for introduction, computer graphics is a field that relies on several core components working together to produce images on a screen. In this assignment, we will focus on five important technical concepts that form the foundation of modern graphic systems. Firstly is shaders, buffers, textures, rendering pipeline, and the model view protection, MVP matrix. Each of these concepts play a critical role in how 3D objects are created, transformed, and displayed as realistic images in games, simulation, and virtual or augmented reality applications. The objective of this presentation is to explain the definition, purposes, and real-world application of this concept, by also illustrating how they contribute to the overall process of rendering computer graphics. So for shaders, the definition is small programs written in GLSL, HLSL, or other shader languages run directly on the GPU to control how pixels, details, and fragments are drawn. So the purpose is to allow custom user effects such as lighting, reflection, shadow mapping, and fonts. Second is to provide flexibility compared to fixed function graphic pipelines. And third is essential for realism in 3D environments. So look at the type of shaders. We have two types. The first is a vertex that transform object vertices. Second is fragment of pixel to calculate color of each pixel. And last is geometry to add or remove shapes. But we still have example in games such as water shaders, create replay and reflection effects, and fire or explosion shaders generate glowing and animated visuals. Second, we go to textures. The definition is a 2D image mapped onto a 3D model to add detail and realism. It can include color, patterns, or surface properties like roughness or shininess. So the purpose is to make simple 3D geometry look detailed, reduce the need for millions of polygons, and create immersive and believable environment. So type of texture, we have diffuse map, basic color of or image. Second is normal map, add small bumps or grooves. As third is specular map, control shininess. The example is a brick wall in a game is just a flat surface with a texture. And character closing details are added using textures instead of complex modeling. And diagram idea is plain 3D sphere, apply brick texture, and it will look like a real brick wall. Like this example I show. And we go to the rendering pipeline. So the definition is a sequence of stages the GPU follows to transform 3D objects into 2D images. It also includes context processing, rasterization, shading, and final output. The purpose is to ensure correct transformation, lighting, and coloring of objects. It also provides a structured workflow for efficient graphic rendering. The key stages is first vertex processing that transform 3D coordinates. Second is clipping to remove parts outside camera view. Third is rasterization, convert geometry into pixels. Fourth is fragment of pixel processing that apply colors, textures, and lighting, and lastly output to playback tool. So we go to the last one that is MVP matrix, a combination of three transformations used in a computer graphic. First is model matrix, the object scale, rotation, translation. Second is view matrix, the camera's position and orientation. Third is projection matrix, that project 3D scene onto 2D screen. So the purpose is to ensure object appear in the correct position, size, and perspective. Without it, object may appear flat, distorted, or misplaced. The GTF in a 3D shooter when the player moves in the camera and replay update the scene instantly. So in conclusion, changes for GPU program for effects, buffers, memory storage for rendering data, textures, images applied for realism. Fourth is rendering pipeline, step-by-step rendering stages, and every matrix ensure correct placement and perspective. So the final note, these components work together to create realistic, immersive, and interactive graphics in games, VR or AR, and simulation. That's all from me. Thanks.